This is for Year 12 Methods. It's 2011 Function Application Tech Allowed Questions 1, A, B, C and D. We have these different tunnels. In the part A it is a quadratic following the rule kx squared plus h. I know from the information that the height of the tunnel at the top is 9, so 0, 9 is a coordinate, and that it is 20 metres wide, so therefore I have coordinates 10 and 0 and negative 10 and 0. So using my calculator, I've got k x squared plus h. And I know that all of that will equal 9 when x equals 0. And if I press execute, that tells me that h equals 9. I also know that it equals 10. It equals 0 when x equals 10. And I can sub in my value for h, which is 9, execute, and if I solve that for k, k equals minus 9, and that's where my answer comes from. Part B is a circle. I know that from the information the height is 8 and that it's 16 metres wide, so therefore that's 8 and 0, negative 8 and 0. So my general rule is f square root g minus x squared, and I know that that is going to equal 0 given x equals 8, and that gives me one incorrect argument, which is a problem here. I'll copy that, edit, clear all variables, OK, action, command, clear A to Z, OK, paste, execute. So one of the letters F, G or X must have been defined at some previous occasion, so by clearing it I was able to fix it up. And I know that it equals 8 when X equals 0, and I'm going to go to simultaneous equations, paste in my two equations and solve them for F comma G, and I get f equals 1 and g equals 64, so there's a 1 there and a 64 there, and that makes sense because that's the equation of a circle with radius of 8. 8 squared is 64. Part C is a linear. I have that straight line and this straight line for different values of x. The information I know that it's 20 metres wide, so therefore that's 10 and that's negative 10. So C will be minus 10 to 0, so minus 10 to 0, and G will be 0 and H will be positive 10, and I need to find the equation. I know I've got negative 10, 0 and 0, 20. That will give me a gradient of 2 and the y-intercept is 20. And here I go from 20 down to 0 over a distance of 10, so that's a gradient of negative 2, 20. But on the calculator, ax plus b, I know that it equals 20, option given x equals 0, and I also know that it equals 0 when x equals negative 10, and I've already solved that b equals 0, so I'll drag and drop that as well, so I've got two given pieces of information, and if I solve that for a, cancel, I take that interactive advanced solve, and I'm solving for a equals 2. So a equals 2 and b equals 20, and the gradient will be negative 2 and the y-intercept will still be 20. And part D, I have a logarithmic function in this general form. Okay, so I have A, the natural logarithm. No, it's not the natural logarithm, it's log base 10 of the modulus of 10 minus x and plus b. So that's my function. And the pieces of information I know that it's 7 high at the greatest point, so 0, 7 is 1 point. So equals 7, option given x equals 0. Cool. So a plus b equals 7 is one equation. And it is equal to this when x is 10 minus 1 over the fourth root of 1,000, y equals 0. Because the roadway was double that, therefore that's going to be half, and that will be the negative 1/2. So I also know from the equation that when x equals 10 minus fraction 1 over the fourth root of 1,000, that y equals 0. And that gives me my second equation. And if I go into graphs and tables, there into simultaneous equations, there's one, there's the other, and I wish to solve that for a and b. And a equals 4 and b equals 3, which gives me an equation which is an answer of 4. Log base 10 of 10 minus x plus 3.